This podcast is sponsored by Click Playground. This free programming environment lets you explore and test your data-driven app ideas using Click's engine and APIs. The goal? Less query writing and more efficiency with associative indexing. Visit playground.click.com to learn more and see it for yourself.
Welcome to the InfoQ Podcast. The InfoQ Podcast is an architecture-focused podcast that discusses innovator and early adopter trends in software. My name is Wesley Reisz, and I chair the English QCons brought to you by InfoQ.com. Today's podcast is with Rossen Stoyanchev. Rossen is a senior staff engineer with Pivotal and a core contributor to the Spring framework. His focus over the last few years has been primarily on the web tier with Spring. Most recently, his work has been around integrations with Reactor and building Web Flux in Spring 5. On this week's podcast, Rossen discusses blocking and non-blocking architectures, upcoming changes with Spring 5, including Reactor integrations, the new Reactive non-blocking web tier Web Flux that leverages kind of an event-style loop paradigm. He discusses the differences between rxJava and Reactor. And then finally, he wraps up previewing his QCon New York talk this June. Thank you for letting us join you on your commute or wherever you may be listening. I hope you enjoy this podcast. Rossen, welcome to the InfoQ Podcast.
Thank you.
Obviously, you've been working on Spring for a bit. What's the main stuff you've been working on lately?
I've been focusing on Spring Framework 5 for about over a year now. The actual preparation started even earlier, but we're currently in fifth milestone, getting very close to the release candidate phase.
What is the target date for the release candidate?
For the release candidate, we're planning to do that very soon at the end of April 25th. And for the GA date, we're currently looking at the end of June, also June 25th.
Awesome. Congratulations.
Thank you. Getting very close now.
Yeah, absolutely. So at QCon New York, which is also coming up in June, you're doing a talk called Servlet versus Reactive Stacks and 5 use cases. We're going to go through that talk a little bit, some of the things you're going to go to, but one of the things that stood out to me in that abstract was you talked about this blog by Netflix that was about Zool. Can you talk a bit about why that's in your abstract and what made you kind of reference it?
Yes, actually, your question brings up the point that my talk at QCon is probably going to be, if we keep the dates, on the exact date of the release of Spring 5 GA. So that's very exciting as a coincidence. The blog post by Netflix that you're referring to, which I decided to bring up in my abstract, is something that I read when it came out by Netflix, and it caught my eye because it represents the same kind of journey, the same kind of experience that we've been working to bring to developers to be able to make that sort of journey. And at the same time, we've been making that journey ourselves, moving from a certain, set of assumptions that we have always had for the last 20 years about what a web stack should look like, working on the Spring MVC, the most widely used Java framework after so many years, and kind of working to reintroduce that same offering, but with new stack assumptions. And that journey that we've been on, when I read that blog post, for me, it was extremely interesting to see somebody of the capacity and caliber of Netflix talking about it, and in very nuanced terms. So I really enjoyed reading that and agreed with quite a bit of it. And it's also nice to see that as that actual results and data points that they present and conclusions.
Yeah, it's a really good article. Let's kind of kick off, and we'll start off kind of at the architecture level in reference back to that article. Actually, when we're talking about kind of a blocking or a multi-threaded type application versus an async system, a non-blocking system, what are some of the things that we need to start to think about?
Well, I think the key differentiation is in the execution model. The assumptions that we've been working with for the longest time is that the servlet container gives us a specific execution model with a pool of threads where each one of those threads is allocated and assigned to processing a specific request. And that makes it very easy for a servlet to take the processing and to not worry about running concurrently with other requests processing the same kinds of data at the same time. And this is a simple processing model that we've been using for a very long time that's served us well and continues to serve us well. But there are certain things that it cannot do as well, and there are certain kind of limitations that it leads to. And it's probably time to revisit some of those assumptions as we now pretty much live in day and age where distributed code is almost a starting point for certain types of applications.
I remember listening to a talk by Katie McCaffrey of Twitter She said something like, if you're writing a system today and it's talking to a database, you're building a distributed system. How has our application development paradigm shifted such that we really need to start to rethink this execution model that you refer to that we've been using for so long?
If you take this traditional approach that we've been using of assigning a thread to processing a request, that makes things very easy to do. But the thread itself may need to do certain things which are asynchronous, and that's probably one of the biggest differences between now and 10, 15 years ago, is that we're no longer even simply calling a database, which is also traditionally kind of a typical asynchronous thing that we may do in a web application. But now it's very common to actually call other REST services and to orchestrate processing in this fashion, which means that you are already dealing with quite a bit of asynchronicity yourself when you deal with processing requests. And that's not the sort of thing for which we're set up in a really good way. I mean, we have, libraries to do asynchronous HTTP calls. We can do some of that, but as far as, making that a first-class citizen of an application in terms of its programming model, we're not quite in that place. Now, over time, the servlet API model has evolved. And for example, in Servlet 3, back in 2009, we saw the ability to do asynchronous request processing, which means that we can separate the processing of the request from the thread which has been given to us by the servlet container. And we can essentially start asynchronous processing and then complete at some point later, which enabled a lot of use cases for decoupling. Say you're calling 3 other services and that's going to take some time. You can return, servlet back to the servlet container. And then when you're done processing, that's when you can complete writing to the response. So that helps enormously. But there's another change in Servlet 3.1, which is the non-blocking I/O. And that's one which is a lot more difficult to introduce into an existing ecosystem, web frameworks and, web applications, because non-blocking I/O goes really deep. In order for you to actually introduce or make use of that part of the Servlet 3.1 API, you might as well forget about most of the other parts of the Servlet API. So for example, something as innocent as getting request parameters in the Servlet API can cause you to block, because that may require parsing the body of the request.
Oh, yeah.
And those are hidden things that are very easy to there's a really good talk by Greg Wilkins that talks about that, and talks about how when you go into the non-blocking I/O side of things, it's pretty much an either-or proposition. You can't mix those two modes. So for example, if you look at the typical servlet processing model, you have a set of filters and then you have a servlet at the end, maybe a web framework doing some processing. When you get to the part of actually processing the request, when you're reading the body, say you're getting request parameters or you're writing to the response body, what it means is that if the client is not able to process the bits that you're writing, if the network connection is slow, that means you got to be able to put that on hold and come back later. And you got to be able to do that as many times as necessary to complete your request. And that's what truly non-blocking processing means. And that's very, very deep change that cannot be done without forgetting many of the existing foundations and contracts that we've been built and have been relying on for a long time.
Yeah, absolutely. So what are some of the use cases that, you just gave some, but what are some use cases where you might want to use maybe a blocking multi-threaded approach versus a non-blocking approach?
It's a little difficult to separate them very cleanly, and it's never black or white separation.
Sure.
And I think that's what the Netflix blocks was really useful in making that very clear, that the picture can be mixed. But one thing that's very difficult to deny is that there's no denying that this is a trend which is very important to be able to address. I think the situations in which where it becomes important is when you deal with increased amount of latency in processing requests. So for example, your web service or web controller processing requests, your server-side application is making calls to other services, and that takes a little bit of time to respond. So you might want to make that call in a non-blocking fashion so that you say, here, go do this work, and when that's done, let me know so I can continue. And it becomes even more important if you're orchestrating, because then you want to be able to declare what are the calls that you want to make, and then you let the reactive library kind of do it in the right order for you, so that you're not calling two things and then waiting for the result and then calling a third thing and so on. And that's really easy to kind of get yourself in a mode that you're waiting longer than necessary, calling threads. The other part is when you're writing back to the clients, you also have a kind of latency there, which is outside of your control. If you happen to be writing or responding to a lot of slow clients over unreliable network, then it's very difficult to calibrate your thread pool because it needs to be as large as the number of slow clients, and that's not something that you can predict ahead of time. Right. And it really goes back to the way we actually first started looking into this, is that we began to see that there are, like Netflix and other companies, that are looking for a different execution model, be able to scale, where if you think about thread pools as a way of dealing with this problem, you need a thread pool at the servlet container. Then you need a thread pool at your HTTP client making calls to other services. Then you need a thread pool for all sorts of other things that you're dealing with that require asynchronicity. So the more asynchronicity and latency is present in what you have to do to accomplish your task, the more you find yourself in this situation of dealing with all sorts of thread pools and trying to ultimately to manage something which is not easy to predict. And that's where the whole topic of resiliency comes, and being able to scale and degrade gracefully. So these are all topics at the center of making these kinds of decisions. But I think in the foreseeable future, for a lot of applications, they're going to dip their toes and they're going to use some of this. And that's what we're aiming to be able to do really well, to take a little bit advantage of this where it makes sense, but to leave it as a choice to you when you want to go all out on doing this full stack.
Sure, makes total sense. When we were chatting before the podcast, you mentioned Node.js was a really good way to think about this trend towards application development in a non-blocking fashion. Can you elaborate a bit on that?
Node.js played a role in kind of bringing to the forefront the whole, notion of what you can do if you didn't have a thread pool to manage. So in their situation, it's not a choice, right? And you really have to do the most with the resources that you have. And it's a really good way to think about this subject, because it shows that if you must use a limited number of threads, it does impose a certain way of doing things. Sure. I mean, if you're on Node.js, you can't just turn around and make a database call. You're going to block the whole server if you don't do this in such a way that you don't block. And if we think about that, then I think that's the kind of execution model that we're looking for, in that event loop style processing, where you take a certain number of threads and you're generally aiming to match the number of cores on your computer, and then you try to stay within those number of threads, and as much as possible not use any extra threads, but instead you're dealing with asynchronous in a different way.
With Node, as you mentioned, they really don't have much of a choice to build this way, right? That's not the case with Java. So I hear you on the benefits of moving to a reactive style of programming level, but there's no free lunch. What are some of the gotchas when you're moving to this non-blocking approach?
That does bring significant changes to the way you program and the way that you deal in general. The impact, if you think about what it means, for example, to use something that we all do in Java, is use a feature or a completable feature. I'm sure everybody's come across that. Or any kind of asynchronous API that will do something and then give you back a promise for the end result, which may be an error or it may be the actual end result. And if you think about that outcome as a kind of event, then you can imagine that if you have a lot of this throughout your application, the more you have this, the more you're essentially dealing with callbacks. And these callbacks, you can think of them as kind of events, and your application and your architecture becomes a lot more event-driven. Yeah. In many ways, for example, another Spring project, Spring Integration, introduced this kind of channel-based and event-driven oriented processing a long time ago, where you have a channel for errors and you have a channel for messages, and it allows you to deal with asynchronicity differently, because you can introduce at any point later, due to this event processing and decoupling, the ability to introduce a different way of dealing with concurrency, different strategies for that. In many ways, we're talking about doing that as the core of the programming model, because naturally that's where all of these reactive libraries like rxJava and Reactor are pointing to, and providing first-class facilities. We've also seen it in Java 8, by the way, and that's a great complement to this topic because Java 8 is a tremendous enabler for all of what we're talking about with the Lambda style programming that enables a more functional approach and makes it much more natural to work with these reactive libraries and for declaring logic. So case in point is the stream API in Java 8 or completion stage and completable future that allow you to use a kind of promise API to declare what should be done in the next stage. This kind of declarative way of breaking down your logic, we're just talking about taking that outside of the realm of simply collections and making that the foundation on which you generally deal with composing asynchronous and non-blocking logic. You're taking an algorithm, you're splitting it up into pieces because each one of those pieces may need to pause before we can proceed with the next stage.
Yeah.
It's the same benefit as using the stream API with collections and now it becomes easier to make it parallelized. It becomes kind of more neutral to whether this is running in the same thread or whether it's happening later in a different thread.
Absolutely. So I did a podcast about a month or two ago with Jonas Bonner, and we were talking a bit about reactive, and I think I said something like reactive is the most overloaded term in software right now.
Yes.
So let's talk about that for a second. You brought up reactive streams, you brought up the streaming API, you brought up rxJava. What are those things, and what's the relationship to Spring 5?
I mean, speaking of Jonas Bonner and reactive streams, and of course, Lightben had a major role in creating the reactive manifesto. So in some ways, and I say this half jokingly, it goes around, it comes back. They started in many ways this movement, and they put a lot of effort, and they created a great standard, the reactive stream specification, also with participation from Pivotal. So I guess that should be a compliment because what they started has taken hold, and it is quite relevant. But essentially, we're talking about a very small and focused specification that can become the foundation for asynchronous libraries and component providers so that they can have a kind of a mini protocol for how they deal with asynchronicity. And especially when you have an event-driven system with the overflow of events, how do we make sure that a producer of data does not overwhelm the consumer of that data? And if you have a collection, if you have the Java 8 Stream API, you're talking about a finite number of items. But what Reactive Streams does differently is that it basically deals with what happens when you have a producer that can produce an infinite number of items and the consumer cannot handle that. A case in point would be, say, in a typical scenario, a full stack web application, you would have some kind of a data provider, and then you have the web application, and then you have the HTTP client. So these are libraries that are coming from different providers. You have a HTTP runtime doing the low-level socket I/O to the client. You have a web framework, you have a web application, then you have a data provider that's fetching data. And you want to make sure that as much as where it is possible, that this is kind of a single chain of events being produced from one end to the other. And as much as possible, if the downstream is not in a position to continue because it's blocking, and again, we're talking about event loop style processing with a very small number of threads. So you don't want to block these threads. When you get to a point where you cannot, say, write to an output stream, and I say output stream, that's the blocking API, but for the non-blocking alternative, you get to a point where you can't write, then you want to send that signal upstream to indicate that they need to slow down. Right. And that's really the main problem that Reactive Streams tries to solve, which we have embraced in the Spring framework in a major way. And a lot of different Spring projects are currently working together with the Reactor project, giving Reactive Streams a very prominent place.
So what about rxJava and specifically Reactor and how it relates into Spring 5?
From a Spring Framework perspective, we're to some degree agnostic. The main thing that we focus on is Reactive Streams as the main contract. What we found as an experience in building our own reactive non-blocking web stack, kind of the parallel to Spring MVC, what we call Spring WebFlux. What we found is that we cannot simply build on reactive streams. Reactive streams are just 4 interfaces, and they're really meant to really solve a very simple protocol problem between disparate providers. But then each library needs to choose its own kind of reactive facilities. And for us, this was the Reactor project. We found very quickly that, we're doing kind of really low-level reactive things to be able to support reactive streams. Yeah. And doing that without a library is basically reinventing the wheel. So pretty much anybody writing a reactive streams publisher from scratch, they should probably ask themselves, is this the right thing to do? Or should I be using a reactive library? So that's what we are doing. We're using Reactor quite extensively as an adaptation to the, we support a set of different HTTP runtimes, including Servlet 3.1 containers, but also things like Netty and Undertow. And then we're using Reactor to composer and declare our own logic. And then on top of that, as a web framework, just like Spring MVC supports controllers to be written in different styles, different flexible method signatures, that actually allows us to very seamlessly support rxJava as well. So if you wanted to use rxJava in your application layer, in your controller, that's something, or maybe you're using a library which gives you back an rxJava observable, then we support that quite seamlessly through a very small set of adapters. But within the framework, we rely on Reactor substantially.
Okay, so let me ask you a question. With Spring 5, that consumes the Reactor project, right?
For the reactive features of Spring 5, you need Reactor as a core dependency.
Okay, it's a dependency. I guess I'm a bit confused. I hear you say you can use a set of adapters to use rxJava in Spring 5, but within the framework itself, you use Reactor. I was under the impression both rxJava and Reactor were each implementations of React streams, and that it was kind of like an either-or type question. So what's the distinction between rxJava and Reactor?
Reactor 3 and rxJava 2 are in many ways very closely aligned. There's quite a bit of very concrete collaboration between the project leads and a lot of sharing of ideas. Of course, they also both participate in the reactive streams specification discussions. The way that I would describe it is that rxJava comes a little bit more from the background of ReactiveX, which is a set of patterns that originated at Microsoft with Eric Meyer and have been adopted in a variety of different languages. So typically a lot of people that come to rxJava, they come to it from the angle of using it for some sort of UI-based work like Android or perhaps the JavaScript version of ReactiveX, the rxJS. Yep. And then it's a natural step from there to also look at rxJava. It just becomes a natural step. But the relationship between rxJava and reactive streams is a little bit slightly more complicated than it is with Reactor, in the sense that a reactive streams comes from a different angle. I think it's more kind of server-side processing minded, the kinds of scenarios that arise there, especially with the concept of back pressure. Right. When Eric Meyer conceived ReactiveX, and to this day I believe he strongly thinks that back pressure, if you're using back pressure, you're not actually doing it right. I believe he said something to that extent. So you can see that there's a bit of a kind of different mindset, and I think a lot of that comes from the fact that rxJava and ReactiveX has been used to solve problems in a user interface style environment where as long as you're reacting to these events, you don't need the concept of back pressure. But I think in server-side applications, the concept of back pressure fits more naturally. Sure. If you're dealing with data and databases, naturally, we already understand that concept, I/O, talking to external processes. And that's where Reactor is in a really good position, because it is philosophically rooted in reactive streams first, and ReactiveX second, but at the same time, it freely borrows all the patterns from ReactiveX. So I think for anybody doing rxJava or had experience with rxJava, if you look at Reactor, you will find that they're very, very similar, and a lot of the terminologies are very, very aligned.
Interesting.
I mean, even within ReactiveX, if you go to the page for ReactiveX that shows alphabetically all the patterns, even within ReactiveX, the different languages have different terminologies in many cases, so they're not like 100%. Matching each other. Yeah. So in that sense, I think Reactor has a little bit more flexibility. It doesn't have that legacy. If you look at the types, you will see also that Reactor has basically Flux and Mono. Yeah. Those are two types, one representing a stream of many elements. The other one is more like Java util optional, 0 or 1. Right. And it's a very simple API story that we've found to work really well, especially in data APIs. It's very important to express something returns a Flux versus a Mono. And you can find that in rxJava as well, but they've separated Flowable as a separate concept, which has back pressure that's more reactive streams oriented. And then you have observable separate from that, which more caters to the ReactiveX community. So I think there's that a bit of a split personality there. But other than that, they're very, very aligned.
Got it. Okay. Earlier, you talked about WebFlux. Can you take a second also and talk about what the relationship between Spring MVC and WebFlux is?
Absolutely. So Spring MVC is actually, despite how it may be in most people's minds, it's not a separate framework. It's not something that is distributed on its own. It's actually part of the Spring framework itself, which has a number of different modules. And it's been that way from the very beginning. So you basically have a Spring Web module with general web support, and then you have Spring Web MVC. The word MVC is not even present in the package structure. If you look at the top package for Spring Web MVC, it's org Spring Framework Web Servlet, which means that MVC is just this convenient name which has been given that has become very, very convenient versus saying Spring Framework's servlet framework. I mean, try to Google that. It would not be very helpful. So in a similar fashion, we went through different phases, but essentially we created, taking a step back, so we could not reuse Spring MVC, the core contracts of Spring MVC as it is, because they very much follow the Servlet API and the same assumptions that the Servlet API makes with blocking I/O around input stream and output stream. So we knew that even though we could reuse a lot of the algorithms and concepts from Spring MVC, I mean, many of the things you do in a web application for REST, etc., they don't really change. We're just talking about turning that into a non-blocking contract. So we essentially created a parallel module currently called Spring WebFlux. It used to be called Spring Web Reactive, which is kind of a more friendly name if you first hear it. But just in the same way as Spring's servlet framework, it's not really catchy. It's not something that you can easily Google. We also needed some sort of a very easy to pronounce and very easy to work with name that's very identifiable, which is how we came up with Spring Web Flux. You can think of it a little bit the way ReactiveX works. So you have rxJava, rxJS, rx, etc. So that rx prefix is basically something which differentiates. So this is a bit like our own terminology, kind of set of Flux related projects that build on top of Reactor, and Flux being, kind of a key part of the APIs that we expose. We thought that was kind of the answer. It's been met with, not always with, the best first reactions, even internally, but people report having grown on them. I hope they're not just, saying that to make me feel better.
Yeah, personally, I think it makes some sense. As soon as you've written a few samples, you use a Flux, this Reactor type that represents a stream of data, and you hear the term web flux, it makes sense. But until you know what that flux is, it does sound a little odd.
It disappears quickly, yeah. And I think when people begin to use more and more, if Flux is a major part of what you deal with, just like the Java 8 Stream API, it really sits in the mind differently, and at that point begins to make a lot of sense after a little bit of usage. So it's one of those things, I think.
Sure. So you said something earlier that I want to circle back to, and it was that Spring MVC is just part of the Spring framework. It's just there. So that implies when we're using WebFlux, Spring MVC is still there. It's still present because it's part of the Spring framework itself. There's nothing that says we must use one paradigm over the other, right?
Correct. In fact, these are modules that are sitting side by side. They share many mechanisms algorithmically, even if not actually in physical code. And there is a lot of code also that sits side by side in the Spring Web module, especially around the lower level encoder, decoder bits, HTTP message conversion. Obviously, Spring MVC is not using directly any of what the reactive side depends on and WebFlux, but those mechanisms are side by side is the important thing. And when people report issues or make requests on one side, they are actually making a request on the other side, whether they know it or not. So it benefits both sides. So I think this is a really nice part of the story.
Yeah, but what that really means to me as a Java developer is if I'm using MVC, I can start using elements of reactive programming once I'm to Spring 5 or at least to Reactor. Is that right?
Correct. In fact, we've come through a little bit of an evolution on that as well. So if you look at the WebFlux module, it's not only about the server-side programming model. It actually contains server-side endpoints, kind of annotated controllers that support Flux and observable, but it also has a functional server-side endpoint programming model which is going to feel and look very different for most developers. But I think it makes a lot of sense for some, especially those who have embraced Kotlin, for example. We find a lot of affinity between those two things. And we also have a functional web client. And I think that's going to be a very interesting feature for those who are currently on Spring MVC and they may be thinking, well, this whole, WebFlux subject maybe not warming up to it very quickly. But I think kind of HTTP client is, something which is relevant these days to a lot of applications. You don't have to be a Netflix to use something like that. And being able to orchestrate HTTP calls to other services with ease and to kind of use all the flat map and map kind of style composition, declaring all the things that you need to do with a modern web client is exciting to Spring MVC users as well. And that's where some facilities are shared, and you can see a situation where existing Spring MVC application, you're not going to use Flux all the way, for your programming model in your controllers, but you can make calls through the web client. You're using a reactive piece from Spring Web Flux.
Yeah, very cool.
And then the other thing that we've done is we support rxJava and Reactor first class, where we can in Spring MVC as a return value. So if you happen to be making a call through the web client, which gives you back a Flux, or using something else which gives you back an observable, just return that from your Spring MVC controller. And we will decouple the thread from the servlet container and take your Flux output as it comes into server-sent events or whatever is requested by the client.
Very cool.
And we think that's the way that a lot of people are going to experience it initially.
Yeah, sure.
And then as their comfort level grows, for some, it's going to be a different experience. There's a certain audience for whom going all out reactive is actually a very important topic. And we want to be there on both sides. And I think that's the unique proposition, is that we're offering ways in which you can take this at different levels of commitment.
Yeah, absolutely. That's pretty awesome. I love it. So we started off talking about your talk at KubeCon New York, servlet versus reactive stacks and 5 use cases. Can you give us a preview? What types of things are you going to address?
Sure. When I wrote the abstract, I thought 5 was a good number. And now I'm thinking, do I have 5? In all seriousness, though, one of the ones I already mentioned, which is that it's very common in a web application to make calls to other services. So if you're using something like the web client, you're orchestrating. So that's one common scenario. And we can take a look at what it means to use that in a WebFlux application versus what it means to use that in a servlet stack-based Spring MVC application. And what's the difference for the processing model, and how does that impact the use of the servlet container thread pool? And what is WebFlux going to buy you that's more compared to doing that on a Spring MVC environment? I think that's an angle that's going to be of interest to most people because they can relate to something that they're using today, kind of an apples to apples comparison.
Absolutely.
Another use case, which I think is in the same vein, the same category, is the use of Spring data, any kind of data provider. So if you're doing like Mongo or Cassandra, Couchbase, and there's others as well, then you can use their async drivers and facilities, and Spring data is gearing up with support for doing that. And essentially, you write an interface and you're getting a Flux or observable with your data. So that's, again, something which I think will be appealing to Spring Web Flux and Spring MVC applications.
Sure, yeah.
It's easy to understand this model. And again, we can talk about making a comparison with those. There are other scenarios also with streaming, both streaming from the client to the server, but more commonly streaming from the server to the client, and what is the impact of that. So that's roughly, the kinds of examples that we'll be talking about and looking at concrete use cases.
Well, I'm looking forward to it. So if you're one of the 6 million Java developers out there listening and you want to know more about what's in store with Spring 5, be sure to check out Rossen's talk at KubeCon New York this June, or look for it in the months following it at infoq.com. Rossen, thank you for taking time to chat with us.
Thank you so much.